In this question, or in this video, I'm going to show you how to calculate the sample standard deviation as well as the population standard deviation by hand. In the future, you're allowed to use graphing calculator about at least once this semester or in your life. We need to carry out this calculation by hand so you know what that standard deviation represents. Well, in short sentence, it represents how spread out your data set is. In the first case, we assume that we have a set of sample. By the end of this video, you will see the difference between the sample standard deviation and the population standard deviation. In the previous module, we already learned how to calculate the mean by hand. All we have to do is to sum all of my data values and then divide it by 5 in this case because I have 5 data values. Oops. So a little bit of calculation shows that my mean is 8.6. Now to find the standard deviation, we need to measure first the difference between my data value and the mean. So I'm going to write the calculation over here. So it's 2 minus 8.6. So that is the distance between the mean and the data value and the mean. Notice the value is negative because my data value is on the left-hand side of the mean. Next one, I have 7 minus 8.6. So still I have a negative value. Same thing over here. And then 14 is above the mean. So notice the difference is positive. And then 13 minus 8.6 is 4.4. Now the next thing I'm going to do is to square the difference. Now let me first do it properly. So clear this. To square this whole thing, notice there is a parenthesis over here, so I will square negative. Notice this is the negative side, this is the minus side. They are different from each other. Negative 6.6. Close the parenthesis and raise to the power of 2. And in this case, I will have 43.56. Now, I'd like to point out that if we do not include this parenthesis, when I square it, I will have a negative sign in front of my 43.56. That would be wrong. The square difference should always be non-negative. It could be 0, it could be positive. Another observation, if I drop that negative sign, 6.6 raised to the power of 2. Notice I have the same value as if I have that negative sign inside the parenthesis. The reason for that is the power means repeated multiplication. So this means negative 6.6 times negative 6.6. Negative times negative is positive. And that's why there is no difference between this expression and this expression. And if I finish this calculation, I will have 2.56, another 2.56, and 29.16. Notice all of my square difference are positive. Sometimes in a very special case, you could have 0, but none of them are negative. So I know that later on, when I sum them up, this is the summation expression. When I sum them up, nothing will cancel out because I know if I add a negative number with a positive number, they cancel with each other a little bit because we are actually carrying out a subtraction. But in this case, I only have positive values. And that is because the way I carry out this calculation, I didn't just sum up the difference. I sum up the square difference. That is because in standard deviation, we're trying to measure how spread out our data values at. So it doesn't matter if whether my data value is below the mean or above the mean. The way we measure them are exactly the same. We are really just calculating the difference, the deviation from the mean. Okay, so when I sum them up, I have 97.2. Very last step, if I'm trying to calculate the sample standard deviation, I will have to divide the summation I just calculated by n minus 1. So in this case, I will have square root of 97.2 divided by 5 minus 1. Square root comes from the fact, balance out the fact that I square the difference. N minus 1 gives us what we call the unbiased estimation for standard deviation. And unfortunately, in this class, there is no simple way of explaining why it has to subtract 1. So unfortunately, it becomes a formula you have to remember. And of course, in this class, eventually you're allowed to use graphing calculator. So other than this question and the very next question, you wouldn't really see the difference. But in your graphing calculator, let me pull out the square root. In your graphing calculator, it always gives you two different standard deviation. And this is the only time I will explain it to you. There are difference between sample and the population standard deviation. So in this case, the standard deviation is 4.93. Assuming we are calculating the population standard deviation, we will have to divide 97.2 by the sample size, which is 5. So I will take the square root of 97.2 divided by 5. Notice I changed the lowercase n to capital N. It's just a convention. If we are talking about population size, we use capital N. So 97.2 divided by 5, close the parenthesis. In my answer, notice the population standard deviation is always less than sample standard deviation with using the same data set. And my answer is 4.41. Okay, so this is how you calculate the sample standard deviation and the population standard deviation by hand. And in this class, it's the only time you have to do so. The whole point of this assignment is to show you the difference between those two standard deviation other than the notation. Forgive me. Let me scroll it down again. Other than the difference between the notation. Okay, so have fun, carry out this calculation. Once we finish that, I will teach you how to use graphing calculator.